Hi, this is Mohit Bhatt from Team CloudOps SRE Squad. I'm working as a DevOps engineer here in XenonStack. So let me take you through a problem statement that we used to face in our projects and day-to-day internal works. So being a DevOps engineer, I was being asked about creating a new Kubernetes cluster every time by our development team and testing team, which was very hectic and time-consuming for us. So for this problem, we started researching about the solution, and in our experimental security task, we got to know about Vcluster, which is a virtual cluster that runs on top of another Kubernetes cluster. Compared to fully separate real cluster, virtual cluster utilizes node groups and networking of the host clusters, while it has its own Kubernetes components and schedule its all workload in a single namespace of the host cluster. Now let's take a look into the components of the virtual cluster. So Vcluster has the Kubernetes components API server, which is responsible for API calls made to the cluster, and then controller manager, which is responsible for maintaining the desired state, and then storage backend like etcd, SQLite, MySQL, and optionally a scheduler, which is responsible for scheduling the pods and all the resources. After that, we have syncer, which is responsible for syncing the resources which we create in the Vcluster into the host cluster. And then, other than this control plane, we have hypervisor in the Vcluster, which is responsible for networking and node group syncing in between the virtual cluster and the host cluster. Now let's talk about the implementation part. So whenever a user executes any kubectl command, it directly goes to the virtual Vcluster control plane inside the host namespace of the host cluster. So inside that, we already explained that there are API server, controller manager, schedulers, syncer. So from Vcluster control plane, it goes to the virtual Vcluster, and then there we can see that there are two namespaces, namespace 1 and namespace 2. Inside that, there are high-level resources such as deployment and CRD. After that, we have low-level resources, pod 1, pod, and let's say service A. So whenever we create any pod or anything, it just gets recreated into the host name, Vcluster namespace of the host cluster with the help of syncer. So syncer is what which generally recreates the pod or any services we create inside the Vcluster. So let me take you towards the few of the benefits of virtual cluster over separate cluster and separate namespace. So we have three parameters here. First one is separate namespace, then we have Vcluster, and then we have separate cluster. Let's talk about the isolation first. So isolation is something for which every organization and client is concerned about. So in separate namespace, we can't expect isolation to be very good. So it is very weak in the separate namespace because it's just a separate namespace, not a separate cluster or something. So talking about Vcluster, the isolation is strong in Vcluster because it is completely like a separate cluster, but it is inside a host cluster. It runs inside a host cluster. Okay. After that, we have separate cluster. So obviously, isolation is going to be very strong in the separate cluster. Alright. After that, we have access for tenants. Okay. So access for tenants means can the tenants get the access over it very easily or not? So in separate namespace, the access for tenants is very restricted, and then in Vcluster we can define the admins for accessing the Vcluster. We can create admins for Vcluster runs inside a separate namespace in the host cluster. So we can create the admin, we can provide the admin role to the tenants, and then they can access the Vcluster. And for separate clusters, we have cluster admins. After that, talking about the cost. So cost is very cheap for separate namespace. It is actually nothing because we are not creating any cluster or anything. We are just creating separate. We are creating a separate namespace only. And for Vcluster, it is cheap because it is occupying the underlying resources of the host cluster, but it is cheap in comparison with separate cluster. And talking about the separate cluster, so if we are going to create separate cluster for each task, it is going to be very expensive and very time consuming as well. Now let's talk about the resource sharing. So resource sharing in separate namespace is very easy, and then it is for Vcluster also it is easy, and for separate cluster it's very hard. Okay, because we have to do cross cluster sharing. So talking about the use cases now, we have two use cases for now. So CI/CD testing is the first one. And use case would be for CI/CD and testing scenarios in a Kubernetes environment. Engineers need to have access to the Kubernetes cluster whenever they need it. So to keep the cost low, the environment should only be run when it is required. So engineers should also be able to modify the Kubernetes resources or configuration to get more access over it. Now the next use case is cloud native development. So more and more companies want to give direct access to the developers to the Kubernetes for during development time. And for this, the engineers need to have Kubernetes access that can work and experiment, that they can work and experiment with, and while keeping the cost and management efforts for the environments very low. Vcluster has really helped a lot to provide various teams different access to different clusters without worrying about the overhead of creating a new cluster for each task. Also, it saved a lot of time and cost for client developers. Working on Vcluster has enhanced my skills in multi-tenancy, enabling me to effectively handle diverse requirements from different teams like development and testing teams. I commend XenonStack for this great initiative, which allows us to dedicate our time in experimenting in different new tools in the industries, which ultimately benefit our day-to-day work. Thank you.